Hey y'all, today we're going to talk about 6.7, which discusses inverse relations and functions. So our essential question here is, how do you find an inverse and why is this process helpful for applications? And then our opening question here is, what does it mean to be a function? So going back to Module A, the first lesson of Algebra 2, we talked about how to find whether a relation was a function or not. So it's important to recall how to determine whether a relation is a function. A relation is a function if your x values do not repeat, okay? So, if you need to refresh yourself, there you go. So, on this page, we talk about what is an inverse, okay? An inverse is where, simply just put it right there, you switch the x and the y's, okay? Now, it's okay if your inverse is not necessarily a function. You can still have an inverse, it just would not be a function, okay? If both the relation and its inverse happen to be functions, then they are inverse functions. Regardless if they are not, though, you would still have an inverse relation. So, for example, you know I'm a visual learner. So, right down here at the bottom, we have a graphic here to help us talk about what is an inverse. So we have our relation R, we have our mapping diagram here. To find the inverse of R, we literally switched the x's and the y's, okay? So here, relation R is a function because only one x goes to a y. But here, when we did the inverse, this is not a function because my x values repeated. Okay, so if you want to find the inverse, all you have to do is switch the x and the y's. So on this first problem here, this shows you a table instead of a mapping diagram. Same thing though, all you have to do is switch the x and the y's. What was the domain now becomes the range, and vice versa. What was the range now becomes the domain. On part B here, they give us the graph, okay, and then they want us to find the inverse. So let's go ahead and take those points and put them in a table so that way we can go ahead and give you the inverse. So that would be 0, -1, 2, 0, 3, 2, and 4, 3. So if I want to find the inverse of relation S, all we do is switch those points. That would be -1, 0, 0, 2, 2, 3, and 3, 4. So what I'm going to do is I'm going to go ahead and plot those points because I want to show you something that a relation and its inverse have. Okay. So if you notice those points, there's something going on with them. There's a certain pattern going on, and I'll go ahead and draw my line in here for you to see that a relation and its inverse, it is a reflection over the line y equals x. And that's going to happen every time, okay? They are truly a reflection of each other over the line y equals x. That's that line here, y equals x. Okay, so that can kind of help you make sure that you graphed the inverse correctly. So on this next one, if you want to go ahead and try this on your own, you're more than welcome to. The first thing I'm going to do is plot these points in blue. So we have, this is just a sideways table, by the way. So we have 0, -5, 1, -4, 2, -3, and 3, -3. So now I'm going to plot the inverse. I really don't like sideways tables. That's just me. I always like them vertically. So I'm going to graph my inverse here in pink. And if I were to draw in that line, y equals x, you would see that they are in fact mirror images of each other. And so I did part one, I did the graphs, and it says, is the relation t a function? Do any of my x values repeat? No, so that is a function. What about my inverse here? My inverse sadly has that -3 repeating, so no, my inverse is not a function. All right. Let's go ahead and talk about if we are given an equation, okay? How do you find the inverse if you are given an equation? Guys, it's the same thing here. You're going to switch the x and the y, and then step 2 is solve for y. I can't tell you how many friends, they just switch the x and the y, and they're like, okay, I'm done. No, no, no. You have to solve for y. So in this graphic here, you can see that they solely just switched the x and the y. The square did not go with the x, okay? Right here. The square did not go with the x. We just switched the x and the y. And from here, we are going to solve for y. So I'm going to add the 1 over. So I have x plus 1 is equal to y squared. And then if I want to get rid of that squared, I'm going to have to take the square root of both sides. And again, you know what to do. When you put in that radical, what do you have to have? A plus and minus. Plus and minus the square root of x plus 1. That is my inverse equation. So all I did was switch the x and the y, and then I solved for y. Let's try that again. For this problem, it says, what's the inverse for y equals 2x plus 8? So I'm going to start with y equals 2x plus 8. I'm going to switch the x and the y. So I have x is equal to 2y plus 8. And now I'm going to solve for y. So I'm going to subtract the 8 from both sides. I have x minus 8 is equal to 2y. I'm going to divide both sides by 2. And we would typically leave it as x minus 8 over 2. However, we do not see linear functions that way. So what we're going to do is rewrite that as we would see y equals mx plus b. So we would say y equals 1/2 x, and then 8 over 2 would give me minus 4. That is a linear equation that we know how to handle. Okay. On this next part here, we are going to graph our original equation and our inverse equation that we got. So I kind of spoiled it for you. I made you solve the inverse first, and we're going to graph the two together, okay? So how would we go about doing this? Well, the first thing I would do is I would make a table of values for your original equation here, and we know how to graph a quadratic. We know our vertex is at 0, -1. So then I would want to plug in my values surrounding that. Let's plug in, so 0, -1. So we would get 0 there and 0 there. If I plug in 2, I would get 4 minus 1, which is 3, and 3. 1, 2, 3. 1, 2, 3. Okay, so here's my original quadratic. And the inverse of the quadratic is the square root. That kind of makes sense. So how will I graph the square root? I'm going to graph the square root by taking my x and y values and just flipping them, like we did at the very beginning. So I'm going to be extra careful here. I should have picked a totally different color. I'm going to do orange. So I have 3, 1, 2, 3, 2, 1, 2, -2, excuse me. Oh, I also have 3, 2 though. 1, 2, 3, 1, 2, 1, 2. I have 0, -1, 0, -1. I have -1, 0. Oh, I forgot 0, 1. 0, 1. 0, 1. And there we go. So by graphing the quadratic and its inverse, we can still see here that they are in fact reflected over the line y equals x. It is just a mirror image over that line y equals x. Okay? Now, fun fact. Okay? If I ask you if this is a function, right? What if I asked you if these inverses and this relation was a function, okay? Does the quadratic pass the vertical line test? Yeah, it does. So that is a function. Does your plus or minus the square root, does that pass the vertical line test? No. And I'll give you a hint here. Anytime you have plus or minus a square root, it will not be a function. Okay? That's very, very helpful here. All right? Last thing in part 1, we're going to do the same thing. We're going to graph the line y equals 2x plus 8. And then we're going to graph the inverse. I believe we got, what was it? Negative, or 1/2 x minus 4. 1/2 x minus 4. Okay, so let's start by graphing our original equation here. We could start at 0, 8 if we wanted to. I think I have 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, okay. So then I can plot some more points here. So what else did I plot? I plotted -1, 6, -2, 4. Right? So if I want to plot the inverse, all I have to do is switch those points. So I would plot 8, 0, I'd plot 6, -1, and I would plot 4, -2. So 1, 2, 3, 4, 5, 6, 7, 8, 0, 6, -1, and -2. And as we can see here, they are still reflections over that line y equals x. Yeah. All right. That is the end of part 1, talking about inverses. On the next part, we'll get a little bit more heavy with some Algebra 2 concepts and the application.